let's see question 17 on establishing identities. The first question said, develop a formula for sine 3a in terms of sine A and cos A. So now let's see, we know that sine 3a is equal to sine 2a plus a. So let's just play around with the value of the angle. So now let's open up using the formula for addition. So this is formula for addition. So let's apply the formula here. Therefore, this will be equal to sine 2a cos A plus cos 2a sine A. Therefore, let's focus on the value of double angle here. Let's open up the formula. For double angle, sine 2a is equal to 2 sine A cos A, and let's rewrite back cos A, plus, then let's open up the formula for cos 2A. This is equal to cos squared A minus sine squared A multiply with sine A. Next, let us multiply this value inside, okay? So you'll get 2 sine A cos squared A plus sine A cos squared A minus sine cube A. Do you realize that this term here is the same? Okay, so 2 of this term plus 1 of this term, this will equal to 3. So 3 sine A cos squared A minus sine cube A. Therefore, you have developed a formula for sine 3a, which is equal to 3 sine A cos squared A minus sine cube A. Now let's read the next question. It says here, hence, meaning that you need to use whatever you have in your hand. So previously, we have the formula for sine 3a that we just developed, so we need to use it inside whatever you need to establish. So let's read the question. You need to show that sine 3a over sine A cos A is equal to 4 cos A minus secant A. So now let's start with our left hand side. Then substitute the value for sine 3a. This is 3 sine A cos squared A minus sine cube A. Divide with sine A cos A. So now do you realize that you have this pattern here of A minus B over C? So let's open up as A over C minus B over C. So let's open up the formula. This is 3 sine A cos squared A over denominator minus sine cube A over denominator. So now let's cancel out sine A with sine A and cancel out cos A in your first term. So the first term becomes 3 cos A. How about the second term? For second term, you can cancel out one of the sine here. So you are left with minus sine squared A over cos A. Next, if you see this answer here and compare it to your right hand side that you need to achieve, you know that the first term here is almost success because you need 4 cos A and now you have 3 cos A. However, the second term here is not established yet. So we need to find secant. Secant is 1 over cos. However, you still have sine here. So let's open up the sine using the formula for identities. So in our identities, we know that sine squared A plus cos squared A is equal to 1. Therefore, sine squared A is equal to 1 minus cos squared A. So let's substitute this value inside sine squared A. You should get 3 cos A minus 1 minus cos squared A over cos A. Now, again, we need to open up this using the formula of simplification like this. So let's open up. Do not touch 3 cos A because this is almost perfect. So just open up the value at the back here. So this should be 1 over cos A minus cos squared A over cos A. So now we can cancel out cos with cos. So now we are left with 3 cos A minus 1 over cos A minus cos A. So now let's open up this bracket here. Multiply minus inside. Therefore, we will have 3 cos A minus 1 over cos A plus cos A. So do you realize that we have the same term here? So 3 cos A plus 1 cos A, this will be equal to 4 cos A. And this term right here, 1 over cos, is equal to secant A. Therefore, we have established our identities. Sin 3A over sin A cos A is equal to 4 cos A minus secant